There's a method that costs less than $3 and takes about 30 minutes. It does not require a technician. It does not require refrigerant. It does not require a single tool that you cannot find in your kitchen right now. And when you do it, your air conditioner does something it has not done in years. It blows ice cold, not cool, not sort of cold, the kind of cold that makes the room uncomfortable within 10 minutes, the kind of cold your unit produced the day it was installed. $3? 30 minutes? And the HVAC technician who is going to charge you $500 to tell you the system needs refrigerant just lost a service call. The problem was never the refrigerant. In the vast majority of underperforming residential AC systems, the sealed refrigerant loop is intact. The gas is still there. The compressor still works. The fan still spins. But there is an invisible layer of filth coating the aluminum condenser fins on your outdoor unit that is slowly strangling the system's ability to reject heat. And that one layer of grime is responsible for higher energy bills, reduced cooling capacity, compressor overheating, and eventually a premature system failure that generates a $3,000 to $8,000 replacement quote. All preventable for $3. Then someone in a corporate boardroom did the math. The HVAC industry generates over $100 billion annually in the United States alone. Residential service calls average between $150 and $500. System replacements average between $5,000 and $12,000. A $3 cleaning method that restores full factory performance and prevents premature failure does not fit inside any of those revenue models. And what does not generate a billable hour does not get mentioned during the service call. Welcome to Forbidden Fix. If these stories matter to you, hit subscribe and the bell. This is where we dig up what industries spent decades trying to erase. To understand why cleaning the condenser coil transforms your system, you need to understand how air conditioning actually works at the physical level. Your AC system does not create cold air. It removes heat from inside your home and dumps it outside. It does this through a sealed loop of refrigerant that cycles between two heat exchangers. The indoor evaporator coil absorbs heat from the air inside your house. The refrigerant carries that heat to the outdoor condenser coil, where it must be released into the ambient outdoor air. The condenser coil is made of aluminum fins packed tightly together, typically at 12 to 20 fins per inch, wrapped around copper refrigerant tubes. Air is pulled across these fins by the condenser fan. As outdoor air passes through the fins, it absorbs the heat from the refrigerant and carries it away. This is the entire mechanism: heat in, heat out. The efficiency of this process depends almost entirely on airflow through those condenser fins. Now here's what happens over time. Your outdoor unit sits exposed to the environment 12 months a year. Dust, pollen, grass clippings, cottonwood seeds, pet hair, dryer lint, spider webs, and airborne grease from nearby cooking all accumulate on the condenser fins. These particles are microscopic individually, but collectively they form a thin, insulating blanket over the aluminum surface. You cannot see it from 2 feet away. The unit looks fine, but at the fin level, each passage between the aluminum blades is partially or fully blocked. Airflow is restricted by 30 to 60%, and when airflow drops, heat rejection drops. The refrigerant leaving the condenser is not cooled sufficiently. It arrives at the indoor coil warmer than designed. The indoor air is not cooled as deeply. The thermostat does not reach set point. The system runs longer. The compressor works harder. Electrical consumption increases by 15 to 30%. And over months of running in this stressed condition, the compressor overheats and fails. This is the single most common cause of premature AC system failure. Not refrigerant leaks, not electrical problems, not compressor manufacturing defects, dirty condenser coils. The Air Conditioning Contractors of America estimates that over 80% of HVAC service calls for reduced cooling performance can be traced to airflow restriction from dirty coils. The Department of Energy states that cleaning condenser coils can improve system efficiency by up to 30%. The information is publicly available. It is simply not profitable to share during a service visit. Before I go further, this video covers the essential cleaning method. Inside the Forbidden Fix vault, I have compiled complete HVAC maintenance guides, including evaporator coil cleaning, drain line maintenance, capacitor testing procedures, thermostat optimization, and the seasonal maintenance checklist that commercial building engineers use to keep systems running at peak efficiency for 20 to 30 years. Everything the HVAC industry charges hundreds of dollars per visit to perform. The link is in the description. But stay right here, because the service industry economics are the part that should change how you schedule every future maintenance call. Commercial building engineers and facility managers have understood the importance of condenser coil maintenance since the invention of modern air conditioning. Every commercial HVAC system in every office building, hospital, and data center in the country is on a scheduled coil cleaning program. Maintenance crews clean condenser coils monthly or quarterly, depending on the environment. The reason is simple. Dirty coils increase energy costs by 15 to 30%, and a single compressor failure in a commercial system costs tens of thousands of dollars. The math makes preventive cleaning mandatory. The same math applies to your home system. But the residential HVAC industry has no incentive to teach you this because your ignorance is their most profitable asset. The typical residential HVAC service call costs between $150 and $300 for a technician to arrive, inspect the system, and provide a diagnosis. The most common diagnosis for a system blowing warm air is low refrigerant. The technician connects gauges, confirms pressures are slightly below nominal, and recommends a refrigerant recharge at $200 to $400. In many cases, the refrigerant charge is within acceptable range, and the real problem is condenser airflow restriction causing elevated head pressure, which mimics the symptoms of low charge on a standard gauge reading. The coil cleaning that would resolve the actual problem takes 15 minutes and costs the company nothing. The refrigerant recharge takes 5 minutes and bills at $300. The incentive structure is clear. When the system is truly failing, the replacement quote arrives. $3,000 to $8,000 for a residential system, $12,000 or more for a high-efficiency heat pump. Financing is offered on the spot. The urgency is manufactured. What is almost never mentioned is that 60 to 70% of premature compressor failures are caused by chronic overheating due to restricted condenser airflow. A compressor that runs with clean coils and adequate airflow will typically last 15 to 20 years. A compressor running with restricted airflow fails in 7 to 10. That 5 to 10 year difference in lifespan is worth $5,000 to $12,000 to the HVAC industry. Multiplied across millions of households, the revenue generated by preventable compressor failures is measured in the billions annually. If you have made it this far, you understand more about HVAC physics and condenser maintenance than 99% of homeowners writing checks for refrigerant recharges their systems did not need. Subscribe and share. One share might save someone $8,000 on a system replacement that a $3 cleaning would have prevented. Here is exactly how to do it. Step 1. Turn off the AC system completely at the thermostat. Then switch off the disconnect box near the outdoor unit to kill all power. Safety first. Step 2. Remove any large debris from around and on top of the unit. Clear plants, leaves, and objects within 2 feet of the unit to ensure unrestricted airflow. Step 3. Mix a solution of mild liquid dish detergent and warm water. Approximately 2 tablespoons of detergent per gallon of water. Use a standard dish soap, not a degreaser. Not a caustic cleaner. Mild detergent is pH neutral and will not damage the aluminum fins or the protective coating on the coils. Step 4. Using a standard garden hose with a spray nozzle, gently rinse the condenser fins from the inside out. Position the hose inside the unit and spray outward through the fins. This pushes embedded debris out in the direction opposite to how it entered. Do not use a pressure washer. High pressure bends and crushes the delicate aluminum fins, which restricts airflow permanently. Step 5. Apply the detergent solution to the fins using a spray bottle or a soft bristle brush. Let it soak for 5 to 10 minutes. The detergent breaks the bond between the microscopic grime layer and the aluminum surface. Step 6. Rinse again gently from inside out with the garden hose. You will see dirty water flowing out, carrying months or years of accumulated filth. Step 7. Let the unit dry for 30 minutes. Restore power at the disconnect box. Set the thermostat to cooling mode. Within minutes, you will feel a difference. Total cost, less than $3 for detergent. Compare that to the $300 service call or the $8,000 system replacement. I need to be honest with you. Cleaning the condenser coil addresses the most common cause of reduced cooling performance, but it is not the only possible cause. If your system has an actual refrigerant leak, evidenced by oil stains on refrigerant line connections or ice formation on the evaporator coil, cleaning the condenser alone will not restore full performance. The leak must be found and repaired by a licensed technician. If the compressor has already suffered internal damage from prolonged overheating, a clean coil cannot reverse that damage. A failed run capacitor or a burned contactor will also prevent proper operation and requires component replacement. If your ductwork has significant leaks, cooled air is escaping into the attic or crawl space before reaching your rooms, and no amount of condenser maintenance will fix a duct problem. This method addresses the most common and most overlooked cause of poor performance. But AC systems are complex and other components can fail independently. Your parents ran their AC systems for 20 years without a single service call. They did not know the engineering term for condenser coil maintenance, but they hosed off the outdoor unit every spring with the garden hose while cleaning the yard. That simple act kept the coils clean, the airflow unrestricted, and the compressor running within its designed thermal envelope. Then the next generation moved into homes with HOA landscaping that hid the outdoor unit behind shrubs. They never touched the unit. They never looked at it. They waited for the house to get warm, called a technician, and wrote a check. There was not a mechanical failure. There was a maintenance failure disguised as a sales opportunity. Subscribe and share. Every share preserves what they tried to erase. The next vault opens soon, and what is inside might explain how a $2 liquid stops a windshield crack from spreading before the dealer quotes you $800 for a replacement.